In this video, we will consider elements that require special processing in mesh analysis. For example, a current source that is part of one mesh only. The circuit shown is planar. It has three meshes defined by the mesh current I1, I2, and I3, where we have taken all three mesh currents to be in the clockwise direction. Recall that in mesh analysis we have to use KVL equations using the mesh currents as the variables and known element values. The 5 ampere current source requires special processing because we cannot write the voltage across the source in terms of the mesh currents and known element values. Also note that the mesh current I1 is in the same direction as the current source, and we can write down that I1 is equal to 5 amperes. Because of the two reasons, firstly that we cannot write the voltage across the current source in terms of mesh currents and other known elements, and secondly because we know that the mesh current I1 is equal to 5 amperes, we will not write KVL for the first mesh I1. Meshes defined by I2 and I3 do not contain any current sources, and we will write KVL for these two meshes beginning with the mesh I2 first. For the 30 ohm resistor as part of mesh 2, we will take a voltage drop in the direction of the mesh current I2 such that the voltage drop across it will be 30 I2 minus I1, and it will be given with a positive sign since the convention we follow is that voltage drops are given a positive sign. There is another voltage drop of 7.2 I2, and finally the last voltage drop of 64 I2 minus I3, and this must be equal to 0 to satisfy KVL. Since we already know the value of I1, we can substitute it in this equation and get the following equation, which we will label as equation 1. KVL for the mesh I3 will give us a voltage drop of 64 I3 minus I2 plus a voltage drop of 6 I3 plus a voltage drop of 10 I3, and this is equal to 0 to satisfy KVL. This will be the second equation that we consider. This gives us two equations in two unknowns, and we can solve for I2 is equal to 3 amperes and I3 is equal to 2.4 amperes. Once we have solved for the mesh currents, we can solve for any other current or voltage in the circuit. For example, if you are interested in the voltage across the 64 ohm resistor with the polarity shown, then this voltage V64 will be equal to 64 ohms multiplied by I2 minus I3, which will be equal to 64 into 3 minus 2.4 is equal to 38.4 volts. To summarize the special processing of current sources in mesh analysis, if the current source is part of one mesh only, then we can write that mesh current in terms of this current source, and we do not write a KVL for this mesh. We write KVL equations for all the other meshes that do not contain any current sources. We will have the same number of equations as unknowns, and we will solve them for the mesh currents. Once the mesh currents are known, we can solve for any other current or voltage in the circuit.